Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the values for a purely capacitive parallel circuit from the Chapter 17 math handout, problem number 9. I'll be taking my known values from the Chapter 17 math handout, and I've got those values highlighted here. So I'm going to take these values from this sheet, and I've plugged those numbers into here. Got my total CT, which stands for capacitive voltage, and all of my capacitive reactance values. Have my frequency as well. From the Chapter 17 formula handout, I have copied the formulas we will need to calculate these values. If we are given capacitive reactance, we have to use formula number 11 to find our capacitance. Since this is a parallel circuit, voltage stays the same as we are shown in formula number 5 here. So our first step is we're just going to fill in all of our voltage values. Our next step, we're going to find our total capacitive reactance using formula number 7. And really, capacitive reactance being measured in ohms is just like resistors in that respect, that we can use the reciprocal formula number 7 to find the total opposition to current flow in a capacitive parallel circuit. So we're going to go 1 over under 120, scroll over, plus 1 over under 60, scroll over, plus 1 over under 40. It equals, that gives us a total capacitive reactance of 20 ohms. Next, we're going to find all of our I values. And if we look at formula number 6 here, it shows us that just like with resistors, current does not stay the same because this is a parallel circuit. So we have to calculate each one of these individually. So we take our 120 volts and we divide it by our 20 ohms. Gives us 6 amps for ICT. Take our 120 volts divided by 120, that'd give us 1 amp. Take our 120 volts divided by 60, 2 amps. 120 divided by 40 gives us 3 amps. Now that we found all of those values, we're going to use formula number 11 to find our total capacitance. So that's going to be 1 over 2 shift, hit your exponent key for pi, times our frequency of 6.366 times 10 to the third times our 20 ohms. And that gives us, well, I don't have enough decimal places. Shift mode setup 6. Let's go with all the decimal places. We hit engineering, 1.25 microfarads. The problem with my calculator there is I did not have enough decimal places showing. So if you go shift mode setup and you hit number 6, it's going to tell you that it gives you the option of how many decimal places you want to show. Well, if you're not showing enough decimal places, it's just going to show zeros. So shift mode setup 6 and go to 9, and that way you've got it all. You hit engineering. Since it gives us the answer in micro, we don't have to do any of the shift engineering again to get it to micro. Alright, so next we're going to change this 20 to 120. Hit engineering. Alright, now see, this one's in nano. So in this case, we're going to go shift engineering because we want all of these answers in micro. So it's 0.208 micro. Alright, in order to get C2, we've got to change XC2. So we're going to change the 120 to 60. Engineering. Alright, shift engineering 0.417 microfarads, and finally we change the 60 to a 40 Engineering, shift engineering, and this gives us 0.625 microfarads. And here's the values here. I simply just copied and pasted them from the Chapter 17 Math Handout Canvas Answer Sheet assignment in the Chapter 17 module of your Canvas page, and these are the values you're looking for. So for our XCT, we're just going to do 20 because we're not going to type in the ohms. 20. For our ICT, we will type in all of the values. Let's see, ICT, so that'd be 6 amps. Then I'm asked for CT, so that would be 1.25 microfarads. And of course, I'm wanting the numerical value, the metric prefix, and the electrical quantity of measure. Thank you.